Hello, this is Mr. Stansbury. I'm going to take you through the notes on using trig ratios. At the end of this, you should be able to say, I can use trig ratios to find unknown side lengths in right triangles, and I can solve real-world problems using trig ratios. Okay, so let's just do this. We're going to just go right into several examples, and I will show you how we do this along the way. So here's the thing. We're solving for x. We're trying to figure out what this side is right here. Okay, they gave us this angle and they gave us that side, and we want to figure out what that side is right there. So what we want to do is we want to use our good friend SOHCAHTOA, if you remember that. SOHCAHTOA. Okay, so here's the way I like to look at this. So find the angle that they gave you besides the 90 degrees. So we have this angle here, and then figure out what side you need and what side you have. So from this angle here, this is the hypotenuse. That's what we have. And the side that we want is across from that, so that would be the opposite. Okay, and then this one over here would be the adjacent. We don't have it and we don't want it, so I don't even label it. It'll make it a lot, I think it feels like it makes it a lot easier that way. So now, opposite and hypotenuse. Now we look over here and figure out which one deals with opposite and hypotenuse, and that's sine, right? So here's what we do. We sine, and if you remember from before, we were always doing sine of, like, from some angle. We actually know the angle now. So it's sine of 29 degrees is going to equal, and sine is opposite over hypotenuse. The opposite side is the x, that's what we don't know, and the hypotenuse is the 17, okay? Now all we want to do here is we just want to solve this thing for x. So we would want to multiply both sides by 17 here. Get rid of that. And the x is going to be 17 times the sine of 29. Okay, so what we want to do is we want to get our calculator. And it's very important to know that this has to be in degrees, because this is giving us angles in degrees here. So somewhere on your calculator it should say DEG. If you've got an older calculator, it might just have a D on there, but you got to make sure you're getting degrees in here. Okay, now what we want to do, I like to put it in just like it says. So I'm going to do 17, and then here's the sine button. Sine, cosine, and tangent are right there. 17 sine of 29. You can close off the parentheses, don't even have to, it should still work. We push enter, and there is our side length. Our side length is going to be 8.24. Let's go to the nearest hundredth. Okay, so x is 8.24 feet. Okay, and that's how you do that first one there. Okay, I just added on to the nearest hundredth for our directions here. So next one here, here's the angle that we have. From that angle, see, we don't have or want the hypotenuse. Across from that angle is the opposite side. Let's do that in blue so we can see it better. Opposite side. And then this here, both of these are adjacent sides, but since this is the hypotenuse, that makes this the adjacent. So now we have opposite and adjacent, which is going to be tangent. So we would want to set up tangent of the angle, 33, equals, and then tangent is opposite over adjacent. So the opposite side is 11. Adjacent side is our x. Okay. Now, there's a couple ways to do this. I'm going to show you the long way, and then I'm going to show you a little bit of a quicker way once we understand the long way. So here's what we want to do. We want to get x by itself. So right now the problem is x is in the denominator. We want x to be in the numerator. So if we multiply both sides by x, we'll get rid of that, and we have x tangent 33, x times tangent of 33 equals 11, right? And since we want to get x by itself, we got to divide by tangent 33, both sides. So we know to figure out x, it's going to be 11 divided by tangent of 33. Okay, and we'll put that into our calculator. I'll show you that in a second. Now, I'm going to set this same thing up. Tangent 33 is 11 over x. Now, if you notice, from here to here, which was basically here to here, the 11 stayed in the same spot, and then the x and the tangent 33 swap spots. So here's what I think of. Whenever I see that my variable's in the denominator, my x is in the denominator, I'm going to switch these two things. So I know that now my x is going to be over here, and my 11 is going to stay there, and now it's going to be divided by tan 33, which is exactly what we have here. Okay? So, to show you how to do that one, it's just like it looks, 11 divided by tangent of 33. And that gives us 16.9. The 8 tells the 3 to get bigger, so 16.94. Oops, 94, and this is meters. Okie dokie. Okay, C. Here's the angle that we have. Let's see, this is the hypotenuse, and this over here is the opposite. We don't want that, so this one here is the adjacent. So hypotenuse and adjacent is cosine. So we would do cosine of the angle, 61, equals, cosine is adjacent, x, over hypotenuse, which is 72. So to get the x by itself, we multiply both sides by 72, right? And we get that x is going to equal whatever we get on this thing here. All right, so we're going to do 72 cosine 61. 72 cosine 61. And we get 34.91 if we round it to the nearest hundredth. 34.91, and this is miles. All right. Okay. Moving on to D. Here's the angle. This over here is the hypotenuse. That's what we want. And this is the side across from it. So that would be the opposite. So let's set this up as, let's see, opposite and hypotenuse is sine. So we would go sine 71 is going to equal opposite, which is 22, over x. Okay, now just like this one up here, when we get x in the denominator, we want to just swap it with whatever's on the other side. So these two things are going to swap spots. So we're going to get x equals 22 divided by sine 71. All right, so 22 divided by sine 71. And that gives us 23.27. And that is centimeters. Okay. This one here, here's our angle. This is the opposite side because it's across from the angle, and this is the adjacent side because it's right next to the angle and it's not the hypotenuse. Opposite and adjacent is tangent. Tangent of 42 is going to equal opposite, which is x, over adjacent, which is 37. The number's in the bottom, so we just multiply, sorry, the constant, multiply both sides by 37. And we're going to get that x equals 37 times tangent of 42. So 37 tangent 42. All right, and we get 33.31. And that is inches. All right, and then F, here's our angle. Let's see, this over here is across from the right angle, so that's the hypotenuse, and this is right next to it, so that's adjacent. So hypotenuse and adjacent is cosine. Cosine 47 equals adjacent, which is 13, over hypotenuse, which is x. The x is in the denominator, so we swap sides with the other one, so we get x equals 13 over cosine 47. And we can calculate that. 13 divided by cosine 47, 19.06. 19.06, and that is millimeters. Okay. All right, let's look at a couple more quick things, and then we'll call it good. Okay. One important thing to know is this thing called angle of elevation and angle of depression. Okay, so from the horizontal, so looking straight out, if you're going up, it's angle of elevation. If you go down, it's angle of depression. Okay, it is Important to note that if you'll notice here, these lines here are parallel because oh look, there's our little signs right there. Those are both from the horizontal. So this actually, from looking up here, looking down to the car, and the car looking up to the person, the angle of elevation from the car up to the person and the angle of depression from the person down to the car is the same. So these angle measures would actually be the exact same. Okay, so if you're looking up, it's elevation. If you're looking down, it's depression. Okay. Let's take a look at this one. Find the height of Birdzilla if she casts a shadow of 12.4 meters when the sun makes an angle of 52 degrees to the horizon. So what we got to do is we got to draw this picture. Okay. Okay, so if you think of it this way, here's the sunshine, here's the horizon. It's always perfectly horizontal, hence horizon. Now if it makes a 52 degree, the sun makes an angle of 52 degrees to the horizon. So this is going to be 52. The nice part about this is this angle right here is also going to be 52 degrees here. Okay, so really what we're looking for is we're looking for this height of, height of Birdzilla here, which will be this right here. We're looking for that X right there, right? The height of Birdzilla. Okay, and it says that she casts a shadow of 12.4 meters. So the shadow here is this length right here. That's the shadow. So that's 12.4 meters. Okay, so we're looking for this piece right here. So just like what we've been doing in the other ones, we have this angle. This on that side there is the opposite side. So this length right here is the opposite side, and this length right here is the adjacent side because this is the hypotenuse. So opposite and adjacent is tangent, right? So tangent of 52 is tangent, so katoa. Tangent is opposite over adjacent, so opposite is what we're looking for. That's the X. Adjacent is 12.4. Multiply both sides by 12.4. Right, to get rid of that, and we get that the height of Birdzilla is going to be 12.4 times tangent of 52. So 12.4 tangent 52, and we get that Birdzilla is 15.87, and this is what meters tall. Okay, so Birdzilla is pretty tall, 15.87 meters. That's about 40 something, almost 50 meters, 50 feet tall. That's a big bird. Okay. All right. That's all we have for using trig ratios. If you have any further questions at all, please feel free to ask in class. Thanks.